In this video, we are going to talk about relations and equivalence relations, the foundational concepts in discrete mathematics, exploring how elements of the set connects, relate, and form structured grouping. So I am Mr. V. Ratanakumar, Head Department of Mathematics, PPG College of Arts and Science. So what is a relation? A relation describes how elements from one set connect to elements of another. Formally, a relation R from a set A to a set B is a subset of the Cartesian product A cross B. So, before you learn about a relation, you should know about Cartesian product. So, Cartesian product is A cross B in set notation, which is equal to set of all ordered pair A comma B, and the first coordinate A belongs to A, capital A in the set A. And the second coordinate B belongs to the set B. And subset rule: not every pair in A cross B must appear, only those that satisfies the defined relationship. The formal definition of a relation: a relation R from set A to set B is a collection of ordered pairs. If A comma B belongs to R, we say A is related to B. So for example, A equal to 1 comma 2 and B equal to 3 comma 4. Then we form a relation in such a way that the first ordered pair is 1 comma 3, 1 belongs to capital A and 3 belongs to capital B. The second ordered pair is 2 comma 4. Here 1 is related to 3 and 2 is related to 4. Each ordered pair captures one connection. The type of relations. Relations are classified by the properties they satisfy. These four types form the backbone of relational analysis. The first one is reflexive. Every element is related to itself. That is A or A, for all A belongs to capital A. And second one is symmetric. If A related to B, then B related to A. The relationship works both ways. And third one is transitive. If A related to B and B related to C, then A related to C. Relationship chain together. And then equivalence. A relationship satisfying all three properties: reflexive, symmetric, and transitive, then the relation is equivalence relation. This is a proper definition of equivalence relation. A relation R on a set A is an equivalence relation if and only if it satisfies all three of the following properties simultaneously. And the first one is reflexive, and second one is symmetric, and third one is transitive. All three conditions must hold. Missing even one disqualify the relations from being an equivalence relation. The reflexive property. A relation R on a set A is reflexive if every element is related to itself. For all A belongs to A and A related to A. Example, let A equal to 1, 2, 3. For A is for R to be reflexive, it must contain 1, 1, 2, 2, and 3, 3. So every element must appear as a self pair in the relation. The second is symmetric. A relation R is symmetric if whenever A is related to B, then B is also related to A. For example, suppose I am having a 2, 5 order pair in the set R, then 5, 2 must also be in R. The relationship is bidirectional, so no one-way connections allowed. And the transitive property. The definition is a relation R is transitive if relationship chain together. Wherever A related to B and B related to C, it follows that A related to C. For example, I have a relation R which contains the ordered pair 1, 2 and 2, 3. Then R should contains 1, 3 to satisfy the transitive property. And the equivalence relation, consider an example r equal to 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 3, and 3 comma 1. So these ordered pairs belongs to the given r, and this r is a equivalence relation because this r contains all the reflexive elements, that is 1 comma 1, 2 comma 2, and 3 comma 3, and it possesses the symmetric property, that is suppose 1 comma 3 belongs to r and 3 comma 1 belongs to r. It obviously holds transitive property too. Key takeaways: a relation is a collection of ordered pairs drawn from the Cartesian product, and reflexive, symmetric, and transitive each describe a distinct structural behavior. And third, an equivalence relation satisfies all the three properties, partitioning a set into equivalence classes. Thank you.